Ever pondered on how the future of microscopy might look? Or how quasiparticles could play a pivotal role in it? From the early days of simple lenses to the advanced electron microscopes of the present day, microscopy has always been at the forefront of scientific discovery. But as we delve deeper into the microscopic world, the quest for better, more precise tools never ceases. Enter quasiparticles, the newest players on the field. Unlike your everyday particles, these chaps are not actual particles. Instead, they're collective excitations that emerge from the interactions of other particles. Imagine a flock of birds in flight. No single bird dictates the flock's movement, but rather, it's the collective interplay of all the birds that forms the beautiful patterns we see. These quasiparticles have some unique tricks up their sleeves too. They can move in ways that seem to defy the very laws of physics, sometimes even appearing to travel faster than light. It's this extraordinary behaviour that scientists believe could revolutionise microscopy, providing unprecedented visibility into structures as small as viruses and as intricate as computer chips. Imagine the possibilities that these quasiparticles could offer in the realm of microscopy. But what exactly are these quasiparticles, you ask? Well, imagine a group of people at a concert. Now think of the wave that moves through the crowd when everyone starts to dance. That wave isn't a physical object, but it behaves like one. It has movement, speed, and direction. That's a bit like a quasiparticle. Quasiparticles aren't actual particles. Rather, they're collective excitations or disturbances in a physical system, like ripples in a pond. They emerge from the interactions of other particles, yet they exhibit particle-like behavior. Now here's where things get really interesting. These quasiparticles have some unique properties. For instance, they can move in ways that defy the typical laws of physics. Sounds like something straight out of a science fiction movie, doesn't it? But it's not. It's real science, and it's happening right now. These quasiparticles can seemingly travel faster than light and create a phenomenon called superradiance. These fascinating characteristics make quasiparticles a subject of great interest for scientists around the world. In essence, quasiparticles are the rebels of the particle world, defying laws and creating new possibilities. Intriguing, isn't it? Now imagine the potential of these quasiparticles in the field of microscopy. Their unique properties could usher in a new era of exploration into the smallest realms of our universe. These particle-like entities, born from the interactions of other particles, could provide a high-definition window into the microscopic world, allowing us to see structures like viruses and computer chips like never before. Imagine gazing into the heart of these structures, observing their inner workings in astonishing detail. Quasiparticles can move in ways that defy the laws of physics for individual particles. This means they could potentially travel faster than light, creating a phenomenon known as superradiance. This could lead to the development of compact and powerful particle accelerators, opening up advanced research capabilities to a wider range of laboratories. The implications are staggering. We could gain a deeper understanding of diseases at a molecular level, or engineer more efficient computer chips. The possibilities are as vast as they are exciting. Who knew that these tiny entities, these quasiparticles, could potentially redefine our understanding of the microscopic world? To get smarter, like and subscribe.